Okay, question 3. So a company employs 90 administrators. The length of time that they have been employed by the company and their gender are summarized in the table below. So over here, again, as usual, I've done all the results in advance of time. So all I want to do is explain every single result. Now, the length of time is given by the x years, so x less than 4, the years between 4 and 10, or years greater than 10. And you've got males and females. Now, let's do this step by step. So one of the 90 administrators is selected at random. So only one person, yep. Find the probability that the administrator is female. Well, that's easy. All you do is look at the female column. So it could be any female. So it could be 9 plus 14 plus 7. And we know it's out of 90 people. So it'll just be all of these over 90, which is 30 over 90 or 1/3. Both works. Now B. Now, given that the administrator has been employed by the company for less than 4 years, so when you use the term given that, we're interested in the area. So that's going to be our total value for the bottom. So given that the administrator has been employed for less than 4 years, so less than 4 years implies that the area is now out of 9 and 6, so it's out of 25 candidates, so 9 and 16. Find the probability that this person was male. So out of 9 and 16, the male person, there were 16 of them. So it'd be 16 over 9 plus 16. And then you can simplify that. So the cool thing about given that is that we usually use the shrunken method. We only select one of the variables or at least some of the variables from the bottom half of the fraction. Now C. Given that the administrator has been employed by the company for less than 10 years. So let's pause there. So less than 10 years refers to these two columns. Because this is less than 4 and this is between 4 and 10. So essentially less than 10 means both of them. So these are all the candidates. So these are all the number of people that was less than 10 years. So we've got 9, 16, 40, and 20. So that will be our area underneath. Now find the probability that this administrator is male. So being male, out of these four people, these four groups is going to be 16 and 20. That's it. You just put it on the top line and simplify. Now last one, D. State with a reason whether or not the event selecting a male is independent of the event selecting an administrator who has been employed by the company for less than 4 years. All right, so this one, not too bad, but we need to think about what it means here. The term independent is usually the common power, the multiplication rule. In the S1 book, you'll be familiar with this one. Independence means that the intersection between A and B must equal the independent probabilities A and B. If you get the same results on both sides, we say they are independent. Now let's do it like that. So selecting male, let's call it M. And selecting someone who is employed for less than 4 years, let's call it X less than 4. So we're looking at this column and we're looking at M. So the probability of getting a male is literally any of these options, 16, 20, and 24. So it'll be 60 if you add them up out of 90. The probability of administrator being who's worked for less than 4 years is anyone from the first row, 9 and 16, so it's 25 people out of 90. So doing that, you should get 5 out of 27. Now, if you're doing the intersection rule, we need to see now the probability of M intersecting with less than 4 years. So if you're male and you did less than 4 years, that counts for exactly 16 people, so 16 out of 90. Now solving this, you get A of 45, and you realize that the probabilities are different. So this implies that they are not independent at all. And that's it.